Sum and difference formulas, Chapter 7, Section 5. So we're going to start with the sum and difference formulas for the cosine function. Cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And I know you may be looking at this and going, oh boy, more stuff to memorize, but remember we have a formula sheet and these are on it. It's really the trig functions and stuff like that that we have on that formula sheet. But if you're trying to remember how this works, when you're dealing with cosine alpha plus beta, notice that the formula for it deals with alpha, beta. So if it's cosine alpha plus beta, it's cosine alpha cosine beta, sticking with the cosine, minus sine alpha sine beta. So we're dealing with cosines, then we're dealing with sines, and we're using the opposite sign, SIGN. Instead of adding, we're subtracting. If we get to the difference formula, cosine alpha minus beta, it's cosine alpha cosine beta plus sine alpha sine beta. But as I said, you don't have to memorize those. We have a formula sheet for that. For the sine function, the signs SIGN match up, but the cosine and sine do not. So we have sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. Now, if you can't remember the order of those, all you have to do is remember that you mix sine and cosine and that it stays addition, because whether you say sine alpha cosine beta plus cosine alpha sine beta or cosine alpha sine beta plus sine alpha cosine beta, it's the same thing because of the commutative property of addition. But again, we have a formula sheet for that. And then with subtraction, this one does matter. Sine alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. For the tangent function, tangent alpha plus beta is equal to tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. In the difference function, tangent alpha minus beta is equal to tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. So now that we've gone through these very interesting formulas that may be a real pain to remember, let's try to use them. So using sum and difference formulas. So I want you to find the exact value of the sine of 5 pi over 12. Now, whenever we're asking for the exact value, it's implying that you're gonna be working with the standard angles. Remember, our standard angles are either quadrantal angles. So, and I'm going to put this in degrees, even though we're dealing with radians here. So 0, 90, 180, 270, 360, or those standard angles of 30 degrees, 45 degrees, or 60 degrees, because it means we shouldn't have to use a calculator to do this. So if we're doing that, then basically we know 5 pi over 12 is not a standard angle, but we're looking for an exact value. So we have to look at it and say, well, can I add two angles together or subtract two angles from one another to get 5 pi over 12? So the sine of 5 pi over 12 is equal to the sine of 3 pi over 12 plus 2 pi over 12. You may look at this and like, I don't remember those, but 3 pi over 12 is pi over 4, or 45 degrees. 2 pi over 12 is pi over 6, or 30 degrees. So we have the sine of 40 plus 30 degrees. So we must be looking at the sine of 75 degrees. But now we have standard angles, if we have standard angles, we can use our unit circle or we can build our triangles. And as I show here, the reduced sine of pi over 4 plus pi over 6. So now we can use our sum formula. And since we're dealing with sine, that's sine alpha cosine beta plus cosine alpha sine beta. So we just substitute pi over 4 as alpha, pi over 6 is beta, and we plug it into our sum of sines formula. And now that we have that, we can use that unit circle. Well, the sine of pi over 4 is the square root of 2 over 2. The cosine of pi over 6 is the square root of 3 over 2. The cosine of pi over 4 is the square root of 2 over 2. The sine of pi over 6 is 1/2. So we can multiply, we get the square root of 6 over 4 plus the square root of 2 over 4. Common denominator, we can add those, and we get the square root of 6 plus the square root of 2 over 4. And just remember, you cannot add radicals together unless they're the same radical. So we can't add the square root of 6 plus the square root of 2. Sorry about that. But that's our answer. Let's try another one. Find the exact value of the tangent of 75 degrees plus the tangent of 15 degrees over 1 minus the tangent of 75 degrees times the tangent of 15 degrees. Now this one seems to be working the other direction. That's not a sum or difference. That's the formula for the sum of tangents. So we can say that the tangent of 75 degrees plus the tangent of 15 degrees over 1 minus the tangent of 75 degrees times the tangent of 15 degrees is equal to the tangent of 75 degrees plus 15 degrees, which 75 degrees and 15 degrees, neither one of those are standard angles, but 75 degrees plus 15 degrees, that's 90 degrees. And the tangent of 90 degrees is 1. So you see that made that really easy to solve once we recognized that formula. Again, and I know I've said this numerous times already, feel free to use the formula sheet. I am not going to require you to memorize all these. So let's go into a more specific case. Find the exact value of sine of alpha minus beta, given that the tangent of alpha is equal to 5/12, where alpha is between pi and 3 pi over 2, and the sine of beta is equal to -1/2, where beta is between pi and 3 pi over 2. Well, what's happening here? Well, remember that those standard angles actually are reference angles. And for any function, that reference angle could go in any of 4 quadrants. And depending on the value, the signs of the trigonometric ratios, that limits it down to 2. If the signs are positive, then there's only 2 quadrants where that particular function would be positive, or if the sign's negative, then that function could only be negative in 2 different quadrants. So looking at these, I see that alpha is between pi and 3 pi over 2, beta is between pi and 3 pi over 2. Well, that means that alpha and beta are both in the 3rd quadrant. Okay, so looking at that, why is that important? Well, that allows us to look at these trigonometric ratios and determine whether x, y, and r are positive or negative. In the 3rd quadrant, x is negative, y is negative, and r is positive. So for alpha, we know that tangent is y over x. Since in the third quadrant, x and y are both negative, then that tangent alpha equal to 5 over 12 tells us that y is equal to negative 5 and x is equal to negative 12. We can then proceed and find r by using the Pythagorean theorem. So the square root of negative 12 squared plus negative 5 squared gives us the square root of 169, or 13. So now we have the last part of that set of three numbers. Then for beta, we can do the same thing. Since x and y are negative in the third quadrant, and r, remember, is always positive. So you never even have to worry about that. R is a distance, so it's always got to be positive. Then since sine is y over r, y must be negative 1 and r must be 2. And then again, we can use the Pythagorean theorem. So x is equal to negative, remember, x is going to be a negative value, the square root of 2 squared minus negative 1 squared, or negative square root of 3. So now that we have all of the parts of our ratios, the x, y, and our r for alpha and beta, we can start building this. So we want to find the exact value of the sine of alpha minus beta. So sine of alpha minus beta, the formula is the sine of alpha cosine beta minus cosine alpha sine beta. And now you can see that we're going to need this x, y, and r for the sine function and the cosine function for both alpha and beta. So we start filling that in. So sine of alpha, sine is y over r, so we're looking at alpha, so we have negative 5 over 13. Cosine of beta, that's x over r, so for beta, that's the square root of negative 3 over 2, minus cosine alpha, again, cosine is x over r, but now it's for alpha, so negative 12 over 13, and then sine of beta, again, y over r, but this is for beta, so negative 1 over 2. Now, if we multiply through, we get 5 times the square root of 3 over 26 minus 12 over 26, common denominator of 26. Then we get negative 12 plus 5 square root of 3 over 26. So it's breaking it down. We have the trigonometric ratios. We know we can easily figure out which quadrant it's supposed to be in. It told us what the angles have to be between. So we can work our way through that. Then once we go into that, we can find the missing values. It gave us, it's really just dealing with, given the trigonometric value of a certain trigonometric function, or a trigonometric ratio of a certain trigonometric function, find all the other trigonometric ratios. Well, that's the same method we're using here, and we're given a quadrant that it's supposed to be in, which is allowing us to narrow it down. And then we're just plugging into this other equation and solving. Okay, well, we dealt with establishing identities previously. So we're going to do that here too. We're just adding in these new functions that we have. So we want to establish the identity that sine of alpha plus beta over cosine alpha cosine beta is equal to tangent alpha plus tangent beta. So remember, when we're establishing an identity, we always start with, or generally, we can almost always say always, we start with the more complicated side, start breaking it down. So I'm considering sine alpha plus beta over cosine alpha cosine beta to be the most complicated side. And I see that the numerator is the sine of alpha plus beta, so obviously I can use that function. So that becomes sine alpha cosine beta plus cosine alpha sine beta over cosine alpha cosine beta. And what I'm going to do here is I'm actually going to break it up. We've brought things together previously. I'm going to break this up because now I have a sum in the numerator, and then I've got this denominator. So can't I break that up into two fractions being added together, or two rational functions being added together over the same denominator? So I can say that sine alpha cosine beta over cosine alpha cosine beta plus cosine alpha sine beta over cosine alpha cosine beta. And we should see that when we've broken that up, in the first ratio, we can cancel out cosine beta. In the second ratio, we can cancel out cosine alpha, leaving us with sine alpha over cosine alpha plus sine beta over cosine beta, which sine over cosine is tangent. So that gives us is equal to tangent alpha plus tangent beta. And we have established the identity that sine of alpha plus beta over cosine alpha cosine beta is equal to tangent alpha plus tangent beta. Okay, so now let's go into inverse functions and using that a little bit here. So this is the same thing. We're just bringing a little more back into it, some other things that we've used. We're looking for the sine of the inverse sine of 3/5 minus the inverse cosine of -4/5. Now, it may look more complicated here, but really we have the sine of alpha minus beta, right? Remember, an inverse sine is going to give you an angle as a result. An inverse cosine is going to give you an angle as a result. So this is really just the sine of the difference of angles. So sine alpha minus beta is what we can use, where we say alpha is equal to the inverse sine of 3/5 and beta is equal to inverse cosine of -4/5. Well, if the inverse sine of 3/5 is equal to alpha, then alpha, the sine of alpha must be equal to 3/5, right? The inverse function, we're taking the inverse sine of the trigonometric ratio and setting it equal to alpha. So the sine of alpha must be equal to that trigonometric ratio, 3/5. And cosine of beta must be -4/5. Again, you've got that trigonometric ratio in there from the inverse cosine. So now that we have that, we can do the same thing we did a couple slides back, where we use the fact that we know what the ratios are for a function with alpha and a function with beta, and we can find the missing piece. So for alpha, we know that y is equal to 3, r is equal to 5. And you may ask, well, wait a second, how do we know that it's not -3? How do we know it has to be +3? Well, sine and cosine both have r in the denominator. Therefore, we know that if there's going to be a negative sign, it's got to come from x or y. If it stays positive, then x or y have to be positive. So we have y equal to 3, r equal to 5, and then using Pythagorean theorem, x is equal to the square root of 5 squared minus 3 squared, or the square root of 16, which is 4. And we can do the same thing for beta. X is equal to -4, r is equal to 5, y ends up being equal to 3. Now, some of you may have noticed 3, 4, 5. Yes, I used a basic 3, 4, 5 triangle for this. So you may not have had to do all the figuring that we just did. So now we can use our formula that the sine of alpha minus beta is equal to the sine of alpha cosine beta minus the sine of alpha, minus the cosine of alpha sine beta. and we can just start plugging those ratios in. So we have sine of alpha is 3/5, cosine beta, -4/5, minus cosine alpha, 4/5, times sine of beta, 3/5. And multiplying through, we get -12/25 minus 12/25. Be careful here. Watch your signs. That gives us -24/25. It did not cancel out. Just be careful of that. That's one of those simple mistakes that people make. So -24/25. So you may want to look through this one just a couple times and make sure you understand what's going on here. It's really not that complicated, but it's just the presentation and wrapping your mind around exactly how that works.